Good day. You're welcome back to MOG Economics. I am Idris, and today we're going to continue our class on Econometrics. So in this class, I'll be taking you through dummy variable regression models. Dummy variable regression models. So before we move on to discussing dummy variable regression model, we actually have to understand what a dummy variable is. What is a dummy? What's a dummy variable? That's the first thing we have to understand. Now, for dummy variable, these are qualitative variables. Yes, we have the quantitative variables. These are the ones you can quantify. Then we have the qualitative ones. Qualitative variable. Now, example of quantitative variables are we have GDP. When we talk about your income, those are quantitative. And what we have been dealing with since from the simple linear regression and the multiple linear regression, we've been working with the quantitative variable. But under this in this class, we're going to be looking at what if we have a qualitative variable in our regression model. So how are we going to treat it? That's what we're looking at. So example of a quantitative variable here are things you cannot really quantify. So let's say we're dealing with sex. We're dealing with level of education. Yes, level of education. So these are some of the qualitative variables you can work with. Before I continue, I would like to say that the variables you have to work with in economics, you want to work with like 4 of them. We have the ratio scale variable, the interval scales variables, the ordinal scale variables, and the nominal scale variables. Now, what are these variables? What's the ratio scale variable, the interval, ordinal, and the nominal scale variable? Now, for the ratio scale variable, now it has basically 3 properties. One of them is, I'll be listing it out here. 3 properties. One is that you will be able to divide. That's division. So it is possible, let's say we have 2 ratio scale variables, x1, x2. So it is possible for you to say x1 divided by x2. So the result you get here will make sense. For instance, if you have GDP as your variable, so if you say, okay, GDP of 2007 divided by GDP of 2008, the figure you get will make sense. Then also you talk about the distance. Let's say x2 minus x1. So you say, okay, what is the difference between the GDP of 2020 and 2019? And that is when you want to calculate your growth rate, you subtract. So distance also makes sense. Then another thing you can is ordering. You can arrange them in either ascending or descending order. Ascending or descending order. So you can order these ratio scale variables. You can order them. So these 3 features now, they are for the ratio scale variables. Now when we now move to the interval scale variables, will only have the last 2 properties of the ratio scale, meaning the distance will make sense, then the ordering will make sense. For instance, if you are talking about time periods, looking at years, let's say 2007, 2008, 2009. If you say, okay, let's do the division. Let's divide 2007 by 2008. Like when you're talking about years now, not numbers. What you get like is not meaningful. But if you're looking at distance, you can say, okay, how many years are there between 2015 and 2003? So that's distance. So you can look at, okay, how many years are there. Then ordering, you can arrange in either ascending or descending order. So the ordinal scales now only has the last feature of the ratio scale. That's ordering. And this ordering will come in where you're talking about, probably you're talking about hierarchy. You're talking about, for instance, you're looking at grades, grade A, grade B, and grade C. So it is not possible to say B divided by A, or it's not possible to say B minus A. No, you can only order them. Okay, this is grade A from 90 to 100, so this is higher, followed by B, followed by C, then followed by D. So that is for the ordinal scale of variables. Then the nominal scale variable now, it has none of the feature of the ratio scale variables. So these variables are mostly called categorical variables, qualitative variables, and the one that is very common is the dummy variable. So when you hear of dummy variables, we're also talking about the nominal scale variables. So an example of this is when you're talking about the sex of a person. You're talking about let's say level of education, and all other things you can think of. Let's say, let me add one to it, geopolitical zones, political zones, yes, and any other example you can think of. So the bottom line is, in dummy variable analysis, what we're working with is we're working with the nominal scale variables. You can also work with ordinal scale variables, but when you're talking about the quantitative variables, you're looking at, okay, either ratio or the interval scale variables. And one thing you should take note is, I've said that before, there are other names you can call your dummy variables. You can call them the indicator variables, you can call them categorical, qualitative variables. So yes, to add to the nominal scale, I just remember you can have your race, then you can have color, and so on. So the dummy variable now, how do we bring dummy variables into our regression model? To incorporate dummy variables into the regression model, what you do is you construct artificial numbers that take artificial variables that take either 1 or 0. So what you're doing is, so if you have a dummy variable, let's say you have sex, and sex can have male, can have female. So what you do is you construct artificial variables. So you denote your sex and male. It is not possible for we to put this in a regression model. So what you do is you denote it by an artificial variable. So it's just like you give it a code, saying, okay, if it's male, 1, then if it's a female, then 0. So in your analysis, anywhere you have male, you put as 1. Anywhere you have female, you put as 0. So that is what you are going to be using in your analysis. Then you should understand that male is 1, then female is 0. So the male is generally to indicate the presence of an attribute, while 0 is otherwise. So another thing I would like to mention is the fact that your regression model, I've said that before, but we can have a situation where your regression model, we have the explanatory variables as dummies. So if that is the case, what you have is an ANOVA model. And before I continue, it is very important that I mention something to us. Um, when we're talking about dummy variables, like what we're looking at here, we are looking at the case where the explanatory variable is a dummy variable, not the explained or the regressand. You understand? So the dummy variable in this case that we're looking at the case where the explanatory variable is a dummy, not the regressand. So we can have a situation where the all the explanatory variables are dummies. So in that case, you call it the ANOVA model. And what's ANOVA? ANOVA is analysis of variance. So you're looking at analysis of variance model where all the explanatory variables are dummies. So if you have about 4 to 5 of them, for instance, you can have a situation where you're looking at the wage rate, the annual wage rate of workers. You want to know whether the sex depends on whether the annual wage of workers depends on their sex. So what will you do? You say, okay, let's denote Y as the annual wage or annual income is equal to is your intercept plus dummy, let's call this plus U high. So you have to specify that, okay, D is a dummy variable for sex. Then you say 1 if male, then 0 if otherwise that is female. So you had already specified that, okay, this is the dummy variable and this is the annual income, or U is what we know already, our random error term. The one thing you should understand is, okay, I'll get to that, but I need to mention it here that you should understand that not the two categories will enter into the regression model, but there is a reason for that. We are going to get to that. Now, I've explained the case where all the explanatory variables are dummies, and we say, okay, I said that is called the ANOVA model. What if we don't have all the explanatory variables as dummies? What if some of them are qualitative, some are quantitative? So you call that the ANCOVA model. That's the analysis of covariance. Analysis of covariance model. So this model now incorporates the two together, qualitative and quantitative. So I want to extend this example now. I say, okay, our annual income depends on sex and the years of experience of the worker. So you can have it that yi equals alpha 1 plus alpha 2 di plus, now what we do normally is to differentiate the qualitative from the quantitative variable, you will change the notation for their coefficient or the intercept. So this will be beta, let's call this beta 1 x I plus u high, where yi is the annual wage of the worker, let's call that the worker. Then di is a dummy for sex, 1 if female, then 0 if otherwise. Then xi is years of experience. Now you will notice something here that I have changed this. Like the first time I wrote if male, 0 for female, then I changed this if female and this if otherwise for male. Yes, it doesn't really matter how you place them. What matters most is that you are aware of how you place them. So if I use this in my example and you use this in your own example, we are expected to get the same answer at the end of the the end of the day. So that is just that on how the dummy variable can be incorporated into our regression model. Now, moving on from there, there are some things we have to take note of in the use of dummy variable in our regression model. And number one is if we see that there are n categories, if there are n categories, say qualitative variable has n categories. Now for the sex that I used, sex has 2 categories, male and female. So I said male is 1, then 0 is female. So since this has 2 categories now, what you are going to do is you introduce 2 minus 1 categories in the regression model. So if a qualitative variable has n categories, introduce n minus 1 categories in the regression model. Now, why are we doing this? And you will also notice that in the example I gave earlier, I wrote it as alpha 1 plus alpha 2 di plus ui, and I said di is a dummy variable for sex, 1 for male, 1 if male, and 0 if female. Now you will observe that there are 2 categories here, male and female, and I introduced just 1 dummy variable here. Why is that? Now, if you refuse to, or if you introduce 2 dummy variables here, let's say you did it as alpha 1 plus alpha 2 di plus alpha 3 d2, let's call it this one, plus ui. That means you have introduced both male and female at the same time, and you have your alpha 1. You'll be running into a very serious problem, which is known as the dummy variable trap. Now, what's the dummy variable trap? The dummy variable trap is a case of perfect collinearity. It's a case of perfect collinearity between the two variables, or the 2 dummies in the model, and your intercept term. What do I mean? I said it earlier that yes, it is the 1 and 0 that will enter into the regression model. So if you have your y as this, then you have your d. Let's say this is d1 and this is d2. And you have your y as 50, 60, 70, 80, 90, 100. Then this is 1 0 1 0 1 0 0 0 0 1 1 1. These are the dummy variables. So what you will be having in this case is, if you sum this with this, that means you carry out an horizontal summation, you will have the answer you'll be getting will be equal to the intercept term, and that will lead to a very serious problem for us in analysis. So there's a way to avoid the dummy variable trap. There's a way you do it. You have 2 options. The first option is to introduce n minus 1 category. So this is the first option. Introduce n minus 1 categories. Since we have 2 categories here, we're just going to introduce one category. Now, the second option is you introduce the 2 categories, but you leave out the intercept term. So introduce the 2 categories, but leave out the intercept term. So that's how to avoid the dummy variable trap. So the second thing we have to note about dummy variable in the regression model is the fact that your analysis is made with reference to the base category. And what's the base category? I have to explain that so you can understand perfectly. Now, I said it that you can introduce, if you have two categories or m categories, you introduce m-1 categories in the regression model. Now, in the case where you have two categories, we have introduced two. We have introduced one because the categories are two here. So what you do is, whichever one that is introduced, let's say you are introducing male, your base category will be the other one, which is the female. And if that is the case, all your explanations, all your analysis, all your interpretations will be made with reference to the base category, which is the female. And your intercept term, the intercept, which is this, will tell us the average or the mean value of the base category. So those are the things you have to understand. So if we move on from here, I say okay, the other thing we have to note is, we say the category for which the volume variable is assigned is called the best matter. I think I've explained that. Then I've explained that. Okay, but let me just write it out. The category for which no dummy variable is assigned is known as, you can call it the base, you can call it the benchmark, and you can call it the omitted category. And number 3 said the intercept term represents the average value of the base category. So these are some of the things you have to take note of while you're working with dummy variable in your regression model. So let's take an example. Let's work with an example. Now, the example we are going to be working with here is, we are going to be working with an example where we're looking at, the wage rate of workers. We're saying the wage rate of workers depends on their years of experience. I think I've used that example before. Then we're looking at something. We're looking at the level of education attained. So if the person finished just primary school, we're going to say, that's one category. Then we have another category, those who finished just those who finished secondary school. So you finished primary school only, you finished primary school and secondary school, that's another category. Then you finished primary school, secondary school, then BSc, that's another category, that's the third one. Then you finish primary school, secondary school, BSc and MSc, that's another category. So our regression model will look like yi equals beta 1 plus beta 2 xi. This is x as the years of experience. We have alpha 2 d2i plus alpha 3 d3i plus alpha 4 d4i plus ui, where yi is the wage rate xi is the years of experience. Then we have D1, 1 if primary school, 0 if otherwise. Then D2, 1 if secondary school, 0 if otherwise. D3, 1 if primary school, no sorry, BSc now, BSc, 0 if otherwise. 1 if MSc, 0 if otherwise. Now, another thing you have to do is now for you to choose your base category. Now, before I move to that, now you look at this model. Is this an ANOVA or an ANCOVA model? Is it ANOVA or ANCOVA? It's obvious. You have a qualitative or a quantitative variable here, which is the years of experience. That's quantitative. Then you have the dummies. You have the dummies here. So you observe that that's a mixture of a quantitative and qualitative variable. So what do? You say, okay, that is an ANCOVA model. Then you will see that the dummy variable, which is the level of education, has 4 variables. That means we are going to introduce 4 minus 1 categories in our regression model, and that is what we have done here. So now the next thing is for you to choose your base category. In this case now, I had chosen primary school as my base category. So all the interpretation will be directed or made with reference to those who just have what primary school living certificate. So D2 years for secondary school and D3 BSc, D4 MSc, and that is what we have done here. So you note that okay, we have introduced 3 dummies in our regression model, and that is because we have just 4 categories. I've mentioned that already. Then I also mentioned the fact that the intercept term represents the average salary of, or the average wage rate of those who have just what primary school living certificates. That was what I mentioned earlier. But in this case now, since we are dealing with an ANCOVA model, what we are going to be dealing with the way we interpret it will change. The way we interpret it will change, and how will that happen? I'm going to show that to us. So to bring this down here. So let's start with the interpretation. Now, if you want to know what the wage rate of someone who has just primary school living certificate is, how will you know that? So we have our regression equation to be 1 plus beta 2 x plus alpha 2 So we're dealing with primary school, those who just have primary school living certificate. So you see that primary school, which is D1, is not in our regression model. That means anywhere you see D1, you're supposed to put 1 there as primary school, but it is not there. So what do? You take the rest as 0, because we have said 0 if otherwise. So that leads to yi equals, there's a way you write that. Say the expected value. So the expected value of yi with D2 equals what? 0, because we are dealing with primary school, and we have said 0 if otherwise. D3 equals 0, D4 equals 0. Then we have xi. So what would that give us? Once you put 0 here, 0 here, 0 here, everything becomes 0. So we have beta 1 plus beta 2xi plus the error term, which is ui. So the expected value, the expected wage rate of those who have just primary school leaving certificate is beta 1 plus this and plus the error term. So of course, so for those with secondary school, for those who have secondary school certificate, that's D2. What will be the expected value of their wage rate? So now, in this case, we're looking at D2, 1 if secondary school. So this will be 1, then D3, 0, D4, 0, then we have XI. So once you put 1 here, then 0, 0 here, everything here goes. So we have beta 1 plus beta 2 xi plus alpha 2 d2. Now this is 1, so 1 times this is still there, plus alpha 2 plus ui. So now you notice something here, that this annual wage rate of those with primary school is beta 1 plus beta 2 xi plus ui, right? Plus alpha 2. Now, the coefficient behind the second dummy variable is telling us something. It's telling us that, okay, the differential effect between those who have primary school certificate and secondary school certificate. So it's telling us that, okay, this coefficient is the difference between those with primary school and secondary school. Because if you take this value, you add it to this. If you take this value, you add alpha 2 to this, you get the value or the average annual wage rate. Now, for those with BSc, that is D3. So I'm saying the expected wage rate is D2 equals 0, and we said that already otherwise. Then D3 equals 1, D4 equals 0, then we have xi. So that will give us beta 1 plus b2 xi plus alpha 3 plus ui. So that gives beta 1 plus beta 2 xi plus ui plus alpha 3. So I mentioned it that all our interpretation will be made with reference to the base category. So you can see the difference here. For secondary school, the difference is alpha 2. For BSc, the difference is alpha 3. Then for MSc, let's see what's happening. That's D4. So we have the special value D2 is equal to 0, D3 is equal to 0, then D4 is equal to 1. So we have xi. So that be beta 1 plus beta 2 xi plus alpha 4 plus ui. So that gives beta 1 plus beta 2 xi plus ui plus alpha 4. So you can see the differential effect. So that is how you treat the regression, the dummy variable in regression model. So let's look at another example so that we'll be able to understand very well. In this case, we'll be dealing with numbers. So I'll rub this off. Another example. So we have yi equals alpha plus. Now the first one we looked at was ANCOVA model, where we have the combination of qualitative and quantitative variable. So in this case, I've decided to use the ANOVA model, where we just have the dummy variable as the explanatory variable. So your y is the annual salary of a teacher. Then the D is a dummy for sex. So use 1 if female, then 0 if otherwise. 0 if otherwise. So what we're looking at here, we're looking at the mean salary. So what is the mean salary of a male teacher? You know, the male teacher is the base category. So what is the mean or average salary of the male teacher? So the mean salary or average salary of a male teacher would be, for a male teacher, that will be expected value of y when d high is equal to 0. You know why is that? Because we already specified that it should be 1 when it is female and 0 when it is male. So that gives alpha plus b, this will be 0 plus ui. That is alpha plus ui. That is the mean or average salary of a male teacher. What about the female teacher? That is ui equals 1. So that will be alpha plus beta 1 plus ui. That's alpha plus beta plus ui. So that gives alpha plus ui plus beta. So this is greater than this by this beta. So the beta shows the differential effect in their salary. So okay, the average salary of a female teacher is beta greater than that of a male teacher. That's how you interpret it. So what if we have this in figures? Let's say we have 18,000 plus 3280 di. So what's going to happen? Well, just like we have it here, alpha is the intercept. So for the male teacher, what are we going to have? In this case, we don't have the error term. So for the male teacher, we're going to have the average salary of a male teacher here to be alpha. So that will give us 18,000. Let's say we're looking at naira. Then for the female teacher, equals 1. That's alpha plus beta. So that gives 18,000. That's what? That's 21,280. I'm not mistaken. So that is the average. So if you look at it, that's okay. The average salary of a male teacher is 18,000. Then the average salary of a female teacher is 21,280. Now the differential effect is 3,280. That's okay. The salary of a female teacher is greater than that of a male teacher by 3,280. So that's how. So even when you have like a lot, you just have to understand which is your base category and you interpret with reference to the base category. Now, one last thing I want to talk about is the interaction effect. You may have interaction in the case where you introduce a dummy variable. In the case where you introduce 2 or more dummy variables in your regression model and you want them to interact. What do I mean? I'm going to explain. Let's say we have this example. Let's talk about the interaction effect. So I have y high plus alpha 1 is equal to alpha 1 plus alpha 2 d2i plus alpha 3 d3i plus beta xi plus ui. So let's define our dummy variable. We say d2 is for sex, 1 if female, 0 if male. Then d3 is for whether university graduate, whether the person is a university graduate or not. 1 if university graduate, 0 if otherwise. So it's possible you have male university graduate, female university graduate. So you want them to interact, because this is only telling us whether male or female. This is only telling us whether the person is a university graduate or not. So you may want a situation where you are looking at a female university graduate. So your regression model now, you have to bring that in. 1 plus alpha 2 d2i plus alpha 3 d3i plus beta. Okay, so alpha 4, then you open a bracket, d2i d3i plus beta xi plus ui. So you have been able to bring them together. I say, okay, what is now the differential effect between the salary of just a female or just a university graduate and that of a female university graduate or a male non-university graduate? You want to know the disparity or the differences between the salaries of these categories. And this just the same way we have done the previous one. That is exactly the way you are going to analyze these two. So nothing is changing, just that you are interacting two or more dummy variables together, so you can have a clearer understanding and you'll be able to interpret clearly. So with this, we have come to the end of our discussion on dummy variables. Do not forget to like this video and subscribe to our YouTube channel. Also share it with your friends and colleagues in other universities. Thank you. I'll see you in the next class.
Please like and subscribe.